I can either do it by hand or I can still do it on my calculator. If I choose to do it on the calculator, which I suggest you do, stat, test, t-test. Data or stats? Data. What list? L1. Frequency equals 1. So go put this list into your calculator right now. Why don't you try it? Why don't I do it also? Stat, edit. Let me clean out my L1 and put this data in. 7, 6, -1, 5, 6, 1. So stat, calc, stat, calc, one variable statistics on L1. So I got my X bar equals 4 and S equals 3.2249. That's what these numbers are coming from. And then that's fine if I want to demonstrate it by hand. So then I took that 4 minus the 0 from the null by 3.2249 divided by radical 6. And I got 3.038. So mind you, this is a right-sided test, so I put the entire alpha in the right tail. So I'm running a t-test with n minus 1 degrees of freedom, where n is 6, so n minus 1 is 5. So let's go to our t-table. 5 degrees of freedom and alpha is 0.05. So 0.05 column and 5 degrees of freedom, 2.015. 2.015 goes right here. It's the critical value. And then I go and I drop my test statistic. I get 3.038, which I go and drop, and it's here in the rejection region. So my conclusion, reject H0 in favor of HA. Meaning, here's my HA, meaning that mu before is greater than mu after. So the test is significant. And in fact, there has been a reduction. That's what this is saying. Mu before is greater than mu after. So there has been a reduction in man hours lost per month. Why cannot we use a confidence interval here? I'm saying this is a right-sided test, therefore no confidence interval is appropriate for this test. Finished. Do you see that it's totally doable? Especially on the calculator. Stat test, t-test, finished. T-test on what? T-test on the differences. Data or stats? Data, every single time. What's the column? Whatever column you put your data in, L1 in this case. So let me do that here. Stat, test, t-test. Data or stats? Data. Mu naught equals 0. That's the mu d, right? Is 0. List is L1. Frequency is 1. We have to pick the side of the test properly. So my test is right-sided, so I'm going to pick that last alternative right here. Hit enter and then calculate. So t equals 3.038. That's what I got also. And p-value I haven't done yet, but they're telling me that the p-value is 0.0144. So it's a very small p-value compared to this alpha of 0.05. P is equal to 0.0144 is less than alpha. Therefore, reject H naught, and the test is significant. Everybody okay here? If you're okay with this matched pairs, I'll move on to something different. Okay. Just want to label these properly. Page 2, page 3. Next, I want to talk about independent samples and the comparison of means. So, when you get home, why don't you guys try page, is there a page 18? Why don't page 18 at home? Let me see. This was 17. And what I will do is I will post the solution to 18 so you can check your work. So the whole key here for the final material is to try to just keep with me so that by the last day of class, we only have two more weeks, right? So by the last day of class, you should be completely comfortable with the material because you're doing problems every single day. Do it that way, okay? So I will post this, and you will have the solution to compare when you get home. Okay? And I'll post these notes today along with this video. Okay. Let's talk about something different. So back to the front of the packet, I want to talk about independent samples. Comparing means for independent samples. Meaning they're not matched pairs anymore. So let's say that I want to see if girls do better than boys on their SAT math. So I have females, males, and I look at the scores for 50 females, n equals 50, and x equals 50, and y equals, let's say, 80 males. And let's say that sigma x is equal to 3 and sigma y is equal to 2. And let's say that x bar is equal to 689. That's the female score. Some smart people here. And y bar is equal to 694. So I have two independent samples here. I have two independent samples, 50 females and 80 males. Thank you. And I want to see if there is a difference in means. So H naught mu x equals mu y versus HA mu x not equal to mu y. Which of course I'm going to bring this back to the left side. This becomes mu x minus mu y equals 0 versus mu x minus mu y not equal to 0. Two-sided test. It's going to be a z test because they gave me sigmas. So z. Two-sided. Pick an alpha. I'm just picking any alpha. Alpha equals 0.10, let's say. So split this alpha into two pieces, 0.05 in this tail and 0.05 in this tail. This is alpha over 2, and this is also alpha over 2. 0 is here. So I'm doing a z because they gave me sigmas. So now the question is, how do I create a test statistic z naught? Do you remember that before, when I was dealing with just one mean, hypothesis testing for one mean, how did I create a z test statistic? Didn't I do this? Let me write somewhere else because I don't want to mess up this problem. We used to do this. Z naught equals x bar minus mu naught over sigma over rad n. That was my test statistic before when I was dealing with only one mean. Remember? The reason why this was the formula for the test statistic is because to create a z value, you have to take whatever it is that you are trying to create a normal distribution for. We're trying to standardize this guy, minus its mean. Take it minus its mean divided by its standard deviation. That's why the formula was what it was. So now in my case, it's not x bar that I'm trying to standardize. I'm trying to standardize x bar minus y bar. So I would have to take the mean of x bar minus y bar, its mean, divided by its standard deviation. So the challenge here is going to be to find the mean and the standard deviation of x bar minus y bar, so I can stick it into this kind of a formula and deal with it. So what is the mean of x bar minus y bar? We write it like this: E of x bar minus y bar, otherwise known as mu x bar minus mu y bar, is equal to E of x bar minus E of y bar. But we have this theorem that says that when you look at the sampling distribution of the means, the mean of that distribution is equal to the mean of x. That was a theorem. So E of x bar is just E of x, which is mu x. And E of y bar is just E of y, which is mu y. So what goes here is mu x minus mu y. And the next thing I'm interested in is this one, the standard deviation of x bar minus y bar. So I need sigma x bar minus y bar. But I also know that sigma is the square root of the variance of x bar minus y bar. So let's start with the variance and then we'll take the square root later. So variance of x bar minus y bar is equal to sigma squared x over nx. Where am I getting that from? Do you remember this formula? Sigma x bar is equal to sigma x over rad n. All I'm doing is squaring both sides here. So go like this. So variance of x bar is equal to sigma x squared over n. That's where I'm getting this from. So variance of x bar is this, plus minus 1 squared. Remember when we're doing the variance, we take the coefficient and we square it? That's what I'm doing. Variance of y bar, which is sigma y squared over ny. So I get sigma x squared over nx plus, this thing is gone because it's just a 1, sigma y squared over ny. That's the variance of x bar minus y bar. I don't want the variance, I want the standard deviation. So standard deviation, sigma